All right, in number 3, we come to something that's a little bit more typical. In the first one, we just had to add them up and take away the terms that appeared on both sides, the chemicals on both sides of the arrow that were the same. In the second one, we had to flip everything. In the third one, we're going to find out that we don't usually have to flip everything. But our target equation is N2H4 liquid plus hydrogen gas reacts to form 2 ammonia and a gas. And we need to find the enthalpy of this reaction. There are 3 reactions with known enthalpies, and they're shown here. So reaction number 1, reaction number 2, and reaction number 3. So my first step, remember, is are things on the right side of the arrow, which is why I line up my arrows. That N2H4 liquid needs to be on the left side of the arrow. And it is. N2H4 liquid is on the left side of the arrow. Good. Hydrogen gas needs to be on the left side of the arrow. Here's hydrogen gas on the left side of the arrow. There's also hydrogen gas on the right side of the arrow. So those are going to cancel. So that means that this hydrogen down here is the one that's going to be able to make it to my final equation. Now, one of the reasons I know it has to be this hydrogen is that on the right side of the arrow I need the ammonia. And this is where the ammonia is. There's no ammonia anywhere else, so I cannot flip equation number 2 over. So I have to flip equation number 3 over. Another reason I need to flip equation number 3 over is that since equation number 1 has N2H4 in the right place, these 2 things have to disappear. These 2 things, CH4O and CH2O, are not in my target equation. They have to cancel out. And the same ones are found in equation number 3, but they're on the wrong side. So I'm going to have to flip equation number 3. And when I flip equation number 3, and I rewrite it, now I've changed the sign of its enthalpy. So I'm just going to cross this one out because we are not going to be using this version. And in combining my reactions, I can see that I'm going to have the pieces that I need. I've got my N2H4 on the right side. I see I can cancel this out. CH4 appears on the left side, then on the right side, canceled out. CH2O cancels out. Nitrogen cancels out. And these 3 hydrogens cancel out these 3 hydrogens. And it's okay because I still have 1 hydrogen left down here, which is exactly what I need. So I can see that I have got my known equations arranged to eliminate everything except the target equation. NH4 plus H2, arrow 2NH3. So I can add them together, and I add these, negative 37, negative 46, and positive 65, and I find out that the enthalpy of my target reaction is negative 18 kilojoules.